Now let's have a look at the VPN part. From HCSA, we will learn how to set for both IPSecVPN and also SSL Vpn. We also support some advanced VPN configuration like plug and play, the dynamic peer, and L2TP, etc., which we will show through the HCSP course. So in this slide, I'm going to show you the basic concept of the VPN, what is IPsec, and how to configure for the IPsecVPN by using both policy-based control and also routing-based control. And finally, how to configure for the Ssl VPN for remote users. The concept of the VPN, I believe most of you guys already had an idea what is VPN. So VPN is the virtual private network that occurs through the public network, which is the internet, and it will provide a significant cost advantage comparing with the specific line connection. And also it will simplify both LAN and WAN operations by using the VPN tunnel communication. And it can help the enterprise quickly start their new services and also connect with a secure channel between their branches and headquarters. And it will provide the security protection for the transmitted data by using encryption, the hash for the integrity verification, and also authentication for the users. This is the typical scenario for the IPsecVPN, which is used to provide or to build a secure communication tunnel between the branch and headquarters across the internet, which can guarantee the connection security through the encrypted tunnel, and also provide encapsulation for the transmitted data between both sides. There are three key elements of the VPN which used to guarantee the secure data transmission over the internet. The first one is confidentiality, which hides and secures the data that transmitted in internet. The second one is the integrity, ensures the transmitted data will not be tampered during the transition. And the last one is authentication, which used to verify if the data source is trusted or not. So first of all, let's have a look at the confidentiality. So confidentiality ensures the data configuration, confidentiality by using the encryption algorithm. And the data encryption is reservable in this case. There are two options for the data encryption and decryption by using either the symmetric key or asymmetric key. The symmetric key is a single key that's used for both data encryption and decryption. It is quite good or suitable for the encryption for large amount of the data because the key length is short, and only one key needed in this case. The commonly used symmetric key algorithm is DAS, 3DAS, and also AES. So both sides, they are using one key. So sender side using this secret key to encrypt the original data and also send the encrypted data into the receiver side, and receiver side use the same key to decrypt the data and get the original or get the original data. So the operation is fast, but the drawback is that because both sides are using same key, if the hackers get this key, so in this case, the data transmission will be not secured. The second one will be the asymmetric key. We are using a pair of keys. So one is called public key, another called private key. And the key length will be longer comparing with the symmetric key, which will have better security. But it will also quite slow when doing the encryption with the symmetric key. So the sender will use the public key that's shared by the receiver to encrypt the data, and only the receiver side has another key, which is private key, to decrypt the data. So in this case, it will be more secure because only receiver has the key to decrypt the data. The second element will be integrity. How we can assure the data is not tampered during the transaction. We are using hash algorithm to protect this data integrity. And it is one-way hash, which means you cannot calculate the original data by reverse the engineering. And you need to compare the output of a fixed length to decide if the data is tampered or not. The most commonly used hash algorithm is MD5 and SHA. Here is the procedure for one-way hash. Firstly, the sender side will put the original data into the hash algorithm to compute for the original hash value, and then it will send this data with the original hash value to the receiver side. The receiver side received this data, and it will separate the original data and also the original hash value, and put the original data into same hash algorithm to compute and get the hash value and then compare this computed hash value with the original hash value sent from the sender side. If both hash value is the same, so that means the data is not tampered. Any small change for the original data will have significant difference in the hash footprint. And the last element is the authentication, which used to verify the data by authenticating the data source. In this, we use the HMAC, which is the hash message authentication code. There are three commonly used HMAC. One is pressure key. Another is IC signature and DSA signature. You can use the pressure key, or you can use the digital signature to authenticate the data source. Here's the hash calculation with the secret key, the hash key. So we add additional hash key into the hash algorithm to authenticate for the source. And for VPN, for the VPN negotiation, actually, we have two SA, two secure association. One is called ICKMP-SA, which is used to protect for the secret key negotiation. And second part is IPSec-SA, which is used to protect for the IP data, For the phase one negotiations, which is phase one, we have two negotiation mode. One we called man mode, another we called aggressive mode. What is the difference for man mode and aggressive mode? If both VPN side, they are using static IP address, we will use the man mode for the negotiation. If one side are using dynamic IP, we need to use aggressive mode. And for phase two, there's only one negotiation mode, which is quick mode. After the basic introduction about the VPN concept, let's have a look how to configure for the IPSecVPN. Here's one typical scenario. We have two sides. So one side I deploy with firewall 1, another side deploy with firewall 2. So if we want to communicate the secure connection between both sides, we can set IPsec VPN tunnel to connect both segments through the internet. In this case, they can communicate. All the internet users from firewall 1 and the internet users from firewall 2, they can communicate with each other. And the user from firewall 1, from site 1, can access the internal resources that located in the site 2. As I mentioned, we can use either policy or route to control for the VPN connection. I will show you guys one by one for the configuration steps. So here is the steps how to configure for IPsec VPN connection. First of all, you need to configure for the VPN instance, which including phase 1 proposal, ICKMP gateway, and phase 2 proposal and IPsec tunnel. After you have all these configured, you can choose either add policy to control for the VPN connection, or use the route, or use the specific routing to control for the traffic. So first of all, we need to configure for the phase 1 proposal. As you can see, we add both web UI configuration and also command line configuration in same page. So in this case, you can compare and take as a reference. So first of all, you need to add for phase 1 proposal. At the device, we already had some predefined proposal for both phase 1 and phase 2, but you can also set your own proposal. So for the phase 1, as I mentioned, you need to choose the authentication method to authenticate the data source. Okay, you can use pressure key. If you use pressure key, you can manually add the pressure key for both sides. Must be the same. Or you can also use the certificate, digital certificate, the ISA or DSA signature for the authentication. And you also need to select the hash algorithm. So which kind of the hash algorithm you want to use. And encryption method, and you can also choose for the DH group, Lifetime, make sure you better use the default lifetime when setting the communication for both sides, which are using Hailstone firewall. For different security vendor, the default lifetime value may different. If you want to set up the VPN communication between different firewalls from different vendors, you need to make sure the lifetime must set as the same value. After the phase one proposal, you need to set for the peer ICKMP, for the peer ICKMP. As you can see here, we need to configure the interface that connected to the peer side, the interface that the used to connect in peer side, and also the protocol standard. Currently, we support for both IKEv1 and also IKEv2, but the IKEv2 only supported to be configured through the command line. But in the future, added to use, and then to configure for as mentioned, using static IP, you use if one using IP, you use this mode, you use and you also need FQ for that, and refer the proposal, the phase one proposal. You use the pressure key. If you use the pressure key, you have the key here. Okay, so let's continue for our presentation for the VPN part. So for the ICKMP configuration, as I mentioned before, you need to configure for the interface that connect to peer, and also you need to select for the protocol standard. By default, is IKEv1. If you want to use the IKEv2, you need to configure through the command line. And man mode, if both sides are using static IP, you use the man mode. If one side using dynamic, you need to use the aggressive mode, and then you need to specify for the FQDN, or you can use DDNS, or you can set for the specific FQDN. And also call the proposal, the phase one proposal here. If you configure as pre-sale key for the authentication, you need to add the pre-sale key, which both sides need to use the same key. And for the advanced configuration, you'd better to set the connection type. If it is bidirectional, or you can set one side as initiator, another side as responder. But normally we can just easily set as bidirectional, so the traffic will be triggered either from the side A or side B. And this is the configuration through the command line. Just give you guys one example. Okay, you need to set all this the same as in UI. After the phase 1, you also need to configure for the phase 2 proposal. Including the protocol, the hash, algorithm, encryption as well. Okay, compression, you can enable or you can just not use that. And also the group, you can set for the group. So that is for phase 2 proposal. And after the phase 2, you need to configure for the IPSecVPN tunnel, which is used for the VPN traffic. So first of all, you need to select your configured VPN peer, the gateway peer, the VPN gateway peer to the tunnel, add it to the tunnel, and also you need to configure the mode for the tunnel. Okay. For site-to-site VPN, we're using tunnel. And also refer the phase 2 proposal here. Proxy ID. If both sides are using Keystone firewall, so the proxy ID you can use auto. So the device, they will automatically negotiate for the proxy ID. Okay, automatically detect for their proxy ID. If not both sides using Keystone, you can configure as a menu and manually add the ID for both internet LAN address, for your local and remote LAN. And also for the advanced configuration, you need to enable the auto connect to automatically trigger the traffic to establish the VPN negotiation. Okay. And this is the configuration through the command line. So proxy ID is the LAN subnet address, as I mentioned, for both sides, which is also the object that you want to protect that through the VPN communication. And you need to enable the auto connect. Otherwise, the VPN connection will not be triggered actively. You need to manually trigger the VPN through the traffic. After you have configured for the VPN instance, you need to choose either to use policy or use the root to control for the IPSecVPN connection. First of all, let's have a look the policy based. If you want to use the policy to control the IPsec, first of all, you need to create the address book for both local and peer LAN. As you can see here, you have local address book and peer address book for the peer side. And then you can add a policy. And use the VPN action control. As I mentioned, for the policy control, you have permit, deny, and you also have VPN control, tunnel and from tunnel. And there is also a direction. If the VPN connection from your local site to peer, so that is through the tunnel. And also for the traffic from peer to your local site is the action well from tunnel. Okay, so you can easily enable the bi-directional policy. So you can only need to add one policy from trust to untrust. Okay, which is from your local to peer, and select as a VPN. The action is a tunnel VPN. And bind the VPN instance here. Okay, and then you just enable the bi-directional policy. So the system will automatically generate two policies for the bidirectional VPN connection. And you'd better to put the VPN policy at the top position of the policy list. Because of the matching sequence, all the new added policies will be put at the bottom. So you need to add the VPN policy at the top, just in case the traffic will be routed through the VPN tunnel. Okay. And then you will have two policies. One is from trust to untrust, from local to peer, and another policy is control the traffic from peer to local. And here's the configuration for the policy through the command line, just for your reference. And because of the policy controlled the VPN, you don't need any NAT. In this case, you don't need to use any NAT. So you need to add a SNAT rule, and the action is no NAT, because no any NAT needed in this case. And then also put this NAT at the top position, So after that, you finished all the configurations for the policy-based IPSecVPN. So first of all, you need to create the address entry for both local LAN and peer LAN, and then the phase 1 proposal, phase 1 Kmppr peer gateway configuration, and phase 2 proposal, phase 2 IPsec configuration. Then you need to add a policy to call this VPN instance, and also add the bidirectional policy to the top position. Finally, add a new NAT SNAT rule, and put at the top position. And the second option, you can use the root to control for the VPN connection. First of all, you also need to create the address book for both local and peer. And then you need to add a tunnel interface, because the traffic will be routed through the routing table to the tunnel interface. So you need to add a tunnel interface, and you'd better to bind this tunnel interface into the dedicated VPN zone. In this case, we can easily differentiate the tunnel interface for the zones. And then you need to bind the IPSecVPN instance into this tunnel, which is the instance we already configured. Select from the drop-down list and add to the tunnel interface. And no any IP needed for the tunnel interface for the IPSecVPN. No any IP address needed. And then we can create a tunnel interface-based destination route. As you can see here, the destination here is the peer side. As you can see here, destination is your peer. Okay, we need to route the traffic to the peer, and next hop is your tunnel interface. Which is tunnel 8, and then add this destination route. After that, you also need a normal permit policy to permit the traffic. It's also bidirectional policy. Okay, one is permit the traffic from your local to the VPN hub, to the tunnel interface. So you need to permit to allow the traffic through the internal trust to the VPN zone, through the VPN zone to the peer. And another is from the peer to your local. you need also bidirectional policy to allow the VPN connection for both sides, for both inbound and outbound traffic. And this is the configuration for route-based VPN. And there is the configuration steps. For route-based VPN, basically you should already have the NAT configured if you have multiple internal users. Okay, you already have the NAT configured. If you use the NAT, in this case, you also need to enable the NAT traversal for the VPN. You also need to enable the NAT traversal. After the VPN configured, okay, the both sides had been negotiated for the proposal, for the algorithm, and finally the VPN will be established. You can check for the VPN status from the web UI. So there is an IPSecVPN monitor. You can check for both phase 1 and phase 2 status. Phase 1 and phase 2 status. And you can also check for both SA through the command line. Show SA Kmppr SA or show IPsec SA to check the status to see is active or not. And through these configuration steps, you can also do some VPN troubleshooting. So if the VPN did not being established, you need to check if you have configured correctly for both ISA AMP SA and also IPsec SA. You can use the show IPsec SA to check for the phase 2 SA and also use show ISA KMP to check for the phase 2. Okay. And after the IPSecVPN, let's have a look the Ssl Vpn configuration. So what is SSL? So Ssl VPN is the VPN connections that between the remote users and the headquarters or internal resources. By using the Ssl VPN, the remote users is able to connect to any of the internal resources or access to the internal systems through internet. Especially during this time period, because of the pandemic, the COVID-19 pandemic, the Ssl VPN becoming more and more popular, especially for those employees who are working from home. They need a solution to access to their internal resources, or they want to access to their internal systems. So in this case, Ssl VPN is a good solution for the remote users, who work from home, who work outside of the office. So for Ssl VPN, first of all, you need to have the access to the internet. And it's more or less used by the remote users through the computer and also through the mobile applications to log into the VPN server and then access to the internal resources. So you need to have some access point, which is the Ssl Vpn client that installed in your PC or in your mobile. So we support the Ssl Vpn client for both iOS and Android. And you also need to have SSL VPN authentication server. So which you can use firewall as an authentication server, or we can work together with the Reduce, LDAP, AD, or TACAS Plus to authenticate for the SSL VPN users, for the SSL VPN users. And here's the SSL VPN client. As I mentioned, you can download the SSL VPN client from our official site, from our official HillstoneNetwork.com. So we support the client for Windows OS, Mac OS, and also Linux OS for the PC, and also support the Android and iOS version for the mobile applications, So you need to download the client, and then you can use the client to access to your SSL VPN server. So how to configure for SSL VPN Thoroughly firewall? We have the Ssl Vpn configuration wizard. You can just follow these configuration steps. So first of all, you need to add a SSL VPN name and also select the SSL VPN server. You can use local. If you use local, you need to create all the users to the firewall. Or if you have your own AD server, so it's better to authenticate the users from AD server without adding additional users to the firewall. So customer have the option to authenticate for different AA server, And after that, after the AD server, the AA server configuration, you also need to configure for this access interface for the SSL VPN. If you have two links, okay, you can select both links so the client can choose any of the egress interface to access to your SSL VPN server. So the address here is the egress interface here is the one interface that the SSL server used to listen to the request from the internet. And also service port, you can change the service port, or you can just keep as a default. And you also need tunnel interface. For the SSL VPN, and also address pool that need to be added, which the device will distribute the IP address from the address pool to the remote users. So you need to configure for both tunnel interface and address pool. So the address of the tunnel interface and address pool should be in same network segment, because the tunnel interface is your gateway for remote users. So they must in the same network segment. This is the tunnel interface configuration, how to configure for tunnel interface. Previously, we mentioned when you're configuring the tunnel interface for IPSecVPN, you don't need to add the IP address. But for SSL VPN, you must add the IP, because this IP will be used as a gateway IP for the remote users. So you must. So first of all, you need binding the tunnel interface into a VPN zone, and then you need to add for the IP address for the tunnel interface. And this IP must be in the same segment, in the same address segment with the address pool without overlapping. So that means the address pool cannot include this IP address. Otherwise, it will be conflicted. And after that, you need to add for an address pool, which the address that you added into the pool will be distributed to the remote Ssl Vpn client, which is used to access to your internal resources. So better to use some un-Euro IP for the address pool of the Ssl VPN, and also this IP cannot contain the tunnel interface IP, And you can also set the DNS server here. So the Ssl VPN server will also distribute the DNS server IP as long as the remote user connected. After that, you need to add a tunnel route. Okay, which will route the traffic through the tunnel interface, As you can see here. So we have the tunnel interface configured. We also need to add some tunnel route. So after the tunnel is established, after the connection has been established, this route, the route here, you added here, will be used to route the traffic to any of your internal resources, or even the resources in internet. So you can add for some tunnel route for your internal resources. And if you want the remote user to use this Ssl VPN server to access to any other internet resources, you can also add the IP address here. And for the computer, for the PC, you can also enable the domain route. To add for any of the domains. For example, you can add google.com. So in this case, all the access to the Google will be through the Ssl VPN server. So that is the route. So this route list will be also distributed from the server side to the Ssl VPN client. Finally, you need to configure the Ssl VPN policy. As I mentioned before, the Ssl VPN tunnel interface needs to be bound to the zone VPN. And in this case, you need to permit the access from your tunnel zone to internal interface, to internal services, which is your internal server zone or your internal resources, internal systems. So that is the direction. So it's single direction to allow the remote users that access to internal resources through the tunnel interface zone. And tunnel interface IP is the gateway IP of the remote users. And after that, you can provide, after all this configuration, you can provide the user login, or they can use their own domain login to log into the Ssl VPN server, okay, through the client. Some questions for the VPN part. So what types of VPN does Hillstone device support? So we support the standard IPsec, SSL. We also support some other VPN deployment like hub spoke, redundant, L2TP, etc. How to configure site-to-site IPsec? What are the steps? I already mentioned before. You need to configure the IPsec VPN through basically through two steps. One is the VPN instance. VPN instance also including phase 1 proposal, ICKMP gateway, phase 2 proposal, IPsec, SA. And then you can choose use policy or route to control for the VPN connection. There are two negotiation modes in phase 1. What are the difference? So two negotiation mode, one is man mode, another is aggressive mode. If both sides using static IP, we use man mode. If one side using dynamic IP, we're using aggressive mode. What are the requirements for the address pool when configuring for SSL VPN? This one I already mentioned before. When you're configuring for the address pool IP, you'd better to use some un-Euro IPs, un-Euro private IPs, just in case if those IPs are used, internally by others, it will lead to any conflict or duplicated. So it's better to use some un-Euro IP for the SSL VPN address pool. And also, the tunnel interface IP must be in the same segment as the address pool and cannot be contained in the address pool. So that is the requirement.